my colleague Bertrand Brandy and myself from the Graie Association will accompany you throughout the morning during this webinar. So as the title say, this webinar is about a comparison of river restoration approaches for large river systems in Northwest Europe, the Rhine and the Rhône. So the ResiRiver project is an inter-regional project that relates to the development and integration or mainstreaming of nature-based solution for great river or big river systems to support their development and their resilience. It's a 5-year project that started in 2023 and that will end in 2028. So it all starts from the observation that nature-based solutions participate or contribute to the resilience of river systems, but we are still facing difficulties in order to develop such solutions. Therefore, we decided to start a European project, which objectives are to develop knowledge and practices in order to promote a greater use of such nature-based solution and to support and scale up or speed up decision-making and the development of public policies in order to support the development of nature-based solutions. It's a quite ambitious project with a budget amounting to 9.4 million euros, which is co-funded by the ERDF, so the European Regional Development Funds. It involves 11 partners that are gathered around the Rijkswaterstaat, which is the Ministry for Water Facilities in the Netherlands. So this is the project holder, and you can see here on the slide the 11 partners that are represented here and that are located in a variety of countries, in France, in Belgium, in Germany, in the Netherlands. And each partner is implementing one or more nature-based solutions on their respective sites that belong, well, as part of the ResiRiver project. ResiRiver is organized around 3 main topics. So the first one is to acquire and exchange experience and knowledge based from nature-based solutions. So basically, we develop knowledge together. We analyze the data, the knowledge. Then the second objective is to transfer the acquired knowledge and experiences to a wider audience, enabling to ensure the capacity building of the stakeholders. And this is why we organize this webinar today. And then there will be a third objective, which is about synthesizing the knowledge in action plans, guidelines, and strategies. Over to you, Bertrand. So today we are gathered for this webinar, and we have various objectives. So the first one is, as the title says, is to see restoration actions that are implemented on the French section and Dutch section of the Rhine and on the French section of the Rhône River. So 2 major alpine rivers with catchment areas shared between various countries and with strong developments. Therefore, it made the comparison quite relevant, and it was interesting to compare the management stakes for both rivers and to have a look at the objectives and restoration practices on both rivers, and finally to identify the restoration practices and see whether they were different or similar according to the context. And therefore, it seemed important to us to be able to share experiences of project holders in order to have a greater overview as regards restoration issues on the Rhine and on the Rhône rivers. So we have EDF, Rijkswaterstaat, and CNR, which will be the main speakers for today. Another objective is to identify issues or topics that can be addressed in a cross-border or cross-waterway manners between the Rhine and the Rhône, and maybe involving more water courses. So we hope this webinar will be the starting point for further exchanges, and we'll come back to this later. Can you move to the next slide, please? So as part of this objective, we organized a webinar in two main parts. So the first part will be dedicated to the presentation of restoration actions in both rivers. So first of all, the French section of the Rhine with a presentation by Agnès Barillet, working at EDF at the Hydraulic Engineering Center, which is based close to Chambéry. Agnès is an hydroecology and environmental expert, and she monitored the restoration of the Old Rhine River, especially in the Camps sector, which is going to present today. The second presentation will be given by Dr. Ralph Schielen, who's an hydraulic and morphological waterway expert in the Rijkswaterstaat, which is the Dutch Ministry for Water Facilities and Water Management, and he's also a researcher at the Delft University. So he's both an expert in research and management. And finally, the third presentation will be dedicated to the French part of the Rhône River with a presentation by Christophe Moirou, who's an engineer at the CNR. He's an engineer in the development of territories and diversity. So he's supervising biodiversity on the Rhône River for many years now. There will be a small coffee break between the second and the third presentations, and each presentation will be also followed by a Q&A session. So you're invited to ask questions via the chat, and we will pass them on to the speakers. So there will be about 15 minutes after each presentation for the Q&A session. So that will be for the first part. And the second part is going to be a panel discussion, so to say, aiming at widening or broadening our thinking and to question operational issues or scientific issues that might be shared between the Rhône and the Rhine rivers, or maybe also involving more water courses. So we will have our three speakers taking part in this panel discussion, and we will also be joined by Fanny Arnaud, who's a research engineer at the CNRS in the field of geomatic and river geomorphology, and she did a PhD on the Rhine restoration, and she's been working at the Observatory for the Rural and Environmental or rural and environment of the Rhône. So she's a Rhône expert, and we will also welcome Professor Martin Pusch, who's a researcher and managing a research group at the IGB on aquatic ecological and fishery in Germany. And he will bring a very interesting highlight on the Rhine restoration from the German point of view. So that's it. So we're going to travel around the two main rivers that you can see here on the map on the right. That's it for today's agenda. I think I did not forget anything, and I suggest that we now give the floor to our speakers. So let's start with Agnès Barillet. Over to you, Agnès. Good morning. Good morning. So I'm going to share my screen. Is it okay for everyone? Okay, so good morning, everyone. Yes, I'm going to talk about a feedback, well, I'll give you a feedback further to the restoration experience on the Old Rhine in Krems. It's a project that started over 20 years ago. So some historical context, the restoration measures or actions, ecological monitoring, main results, and synthesis. So as regards to context and history, this is the German-French part of the Rhine. It's the so-called Upper Rhine part. On the upper part, which is based to this, well, so close to Switzerland, when the Rhine exits Switzerland, enters Germany and France, and so at the border, basically. So basically, this is the basal valley. It's a 50-kilometer long sector. It is operated for hydro electric facilities in what we call the Grand Canal, so the Great Alsace Channel, so between Brezac and Kemps. So it's a section that is about 50 kilometers, and that is bypassed by the Alsace Great Channel, the Grand Canal d'Alsace. So this great channel is the one that enters in and creates this bypass. It's the oldest development of the Rhine power station on the French part. It dates back to 1932. So there you can see a picture of the dam in the 30s, and also the Kemps power plant in 1932 here. And you can see that the water here is turbined and then returned to the former Rhine bed, which was already pretty much developed. And we're looking at the picture underneath. You can see that a little bit later, the channel was extended towards a new power plant. So this represents 4 power plants that are developed on this Grand Canal Great Channel, and that were developed progressively throughout the 30s and the 50s. The last one was finished in 1959. So every time the water was returned within a specific area downstream from the plant, that was then blocked. So, and we used those areas when we wanted to operate the downstream part of the channel. So these Rhine developments are not only about hydroelectric power, they were preceded by big works that took place at the end of the 19th century for navigation purposes. And at that time, an engineer called Tula decided or chose to channelize the Rhine in order to ease navigation. So there you can see a map in the 1830s. So the first work started in 1872, channeling works, and this led to a strong decrease, a sharp decrease of the Rhine biodiversity, a decline of the Rhine biodiversity, because the Rhine was completely incised, and instead of having a 2-kilometer wide alluvial plain, it created a big wide channel, which led to a strong incision that was partly stopped by the development of groins and weirs that you can see here on these archives pictures. So these developments enabled to slow down the incision, but the riverbed was only stabilized further to the bypassing, so the diversion and the regulation of the Rhine flow rate, about 400 cubic meters per second in the Grand Canal, Great Channel. So there you can see on this profile how strong the incision triggered by those works was, with great consequences or dramatic consequences on the riverbed. These translates on the cross section. This translates by an incision that is between 7 to 10 meters in some specific areas. So as you can see here, the groins were developed and played a role in the old Rhine meanders, and they were heightened in some sections. So now we have more homogeneous bed sections, as you can see here, with some areas that have been planted, or where the vegetation grew again progressively. So basically, the conclusion after 1.5 century of developments is a strong reduction of biodiversity in a very monotonous Old Rhine, with only a few spots where the biodiversity is a bit more interesting. When we started the restoration process, well, basically the renewal of the Kemps concession, which was the first one to be renewed in the years 2000, we started thinking collectively. So we organized a major consultation process involving all the stakeholders in order to try and define what was the desired condition and desired objectives that could be associated with the renewal of the CAM's concession, or operating license. So the consultation took place over 4 to 5 years with the three countries, France, Germany, and Switzerland, 20 local authorities, 18 NGOs, so many work meetings that led to main topics. So basically the main environmental topics that were debated at that time in the years 2004, 2005 were issues relating to the minimum environmental flow and this issue of continuity, and namely regarding the salmon, with the objective to have the salmon back to Basel by 2021. There were other topics that were addressed, like flood protection, energy consumption, so finding the right balance between the compensation water, the ecological flow, and the produced energy. And there were also issues around tourism and people visiting the Rhine River. So after the consultation process, we decided to basically tackle this issue of compensation water. And basically, we noticed that increasing the compensation water by itself would not enable to achieve ecological objectives and to restore population of species like the salmon in this section of the Rhine, because the old Rhine riverbed was very much paved, and there was a lack of granulometry and substrate. So we decided to associate the increase of the compensation water of the fixed minimum water flow to increase it with an injection, a replenishment of gravel. And we also wanted to restore the ecological continuity at dam level for fishes and for aquatic mammals, but also at plant level in order to restore continuity between fishes that are located in the Great Channel, in the Grand Canal, and in order to enable them to access a wetlands network that is located on the left bank of the Rhine River. So the key works that enabled to achieve these objectives was the new power plant that was called the K power plant, which is used to turbine the compensation water, and that is located at the same level as the Kems Dam. It is a multifunctional plant which enables to arrange upstream and downstream migration towards the small Rhine and the old Rhines. It mostly enables to have a very fine tuning of the fixed minimum flow towards the Rhine River. Basically, we integrated a seasonal variable, but also a daily variable. And it's this plant that enables to modulate this variable, and this also enabled to reduce the energy losses, as well as feeding the small Rhine with the flow rate and the associated refuge areas. Regarding the ecological continuity, very quickly, I'd like to show you some pictures of the passes that were developed. So we have fish structures between the Great Channel and the other parts. So it enables to bypass the Kemp's plant in order to reach wetland networks. You also have a fishways that were developed between the Old Rhine and the Small Rhine. So there you can see the works performed in 2018. So it's a semi-natural pass. And finally, the spawning run, the upstream migration that was arranged from the plant towards the Old Rhine and the Small Rhine. So we also have counting devices enabled to identify where the fish comes from. And on the right bank, finally, and on the German side, we developed a beaver pass in order to bypass the Kemp's Dam. So the small Rhine in the end, is an aquatic connection that enables to recreate habitats that are very much diversified, that do not exist in the old Rhine anymore because it has been too much incised. So it enabled to recreate this habitat diversity within the former farming plain that was used up until 2008. And we also developed a wooded channel with the aim to rehumidify the forest. So it was not so much for fishery or fishing purposes, but rather to have a wooded forest. So these are the pictures of the small Rhine after a few years of development. And in connection with this, we decided at the time to recreate an entire mosaic of humid and dry environments, open or wooded, over about 100 hectares in order to support the rewilding, the renaturation of this area. So there you can see some figures. So this part was a former cornfield and was kind of designed. We recreated aquatic channels, and these sectors have been planted as well. So this was done after a collect of seeds and cuttings that were collected in the so-called Petite Camargue, small Camargue, that were raised or grown in a nursery during 3 years, and then it was planted, and the works lasted. The planting works lasted about a year. So basically, in order to do that, we had to identify, using such documents, we had to identify and try to come closer to what the floodplain looked like in the old Rhine before the Chula works. And we wanted to re-establish multi-thread channels. So we've been able to recreate former channels of the Rhines, and we tried to stick to this to recreate the new small Rhine while developing habitats all around, diversified habitats that are representative of what the alluvial plain looked like in the 19th century. This was a quite long process to obtain administrative authorizations in 2012. So after the study years between 2004 and 2010, then in 2012, we got the administrative authorizations. In 2013, we started the works with pyrotechnic decontamination because this area was pretty much bombed during the war. In 2014, we started the temporary flooding or filling with a siphon system because there was some delay in the works. So we had to use a siphon system in order to feed the Rhine until the plant was commissioned, because they were delayed in the plant works. So the works ended in 2015, 16 for the planting works, and then we started operating this area through grazing. So it's a great compromise in terms of uses and biodiversity. So basically the objectives were defined according to a number of groups, taxonomic groups. So invertebrates, birds, fish species, taking into account all the uses and the flood risks. So based from that chart, from that table, we try to identify seasonal flow rates, so winter, summer, minimum and maximums. And the consultation then led to the introduction of what was called a daily variable and progressive transitions in spring and in fall, in order to reconcile the projects that were led on the right bank. So this all enabled to introduce a kind of variability in the Rhine regime, Rhine pattern. As regards the sedimentary restoration, the studies had shown that there was nothing much happening since the Kemp's Dam restoration. There were not so much gravel reaching this area, and therefore it was necessary to replenish or to re-inject sediment materials. So we offered two devices. So first of all, sedimentary injection using the excavated material that had been excavated for the K plant and the runoff channel. So they were re-injected in the old Rhine in bars or in strips. And then we used another device called controlled erosion. So basically this is about removing the tuller dikes facings, so in a mechanical way, and then letting the floods play their parts so that the floods could attack the former alluvial terraces and therefore bring gravel progressively in the old Rhine. So there were various pilot sites. So there you have the example of the O3 site, just before and after a flood and the works, and here over 10 years after the works.
In terms of the sedimentary replenishment, it was very much an experimental approach. And we drew on the Interreg program, which was led from 2009 to 2012. And then we continued with research agreements, which were bilateral between EDF, CNRS. So we could understand how these gravel banks were moving, how the sediment was moving, the ecological impact of this. And there were several PhDs supporting this, including Fanny's and Valentin Charnon as well. So from these elements and this feedback we had, we developed this controlled erosion concept, particularly for the sites which were in bank areas, and we experimented with this new concept which mixes sampling and re-injecting materials into these banks. We have the O2 site here in 2022, where we sampled material from there and we re-injected into the main channel. So this is the summary of the measures carried out. And just to let you know here that we will be starting a new project this autumn with a different concept again. In terms of the ecological monitoring that we've set up, the two different types. Firstly, regulatory monitoring with ecological indicators, which is related to this review clause in the contract. There are 4 different stations for the study throughout the river, each 1 kilometer long. And we study all the different aquatic compartments here with different protocols, which are compatible with the Water Framework Directive. And this is done every 3 years. And we also have data from the flooding along the old Rhine, particularly through topobathymetric LiDAR surveys. And then we have adapted monitoring on all the sites, which aims to characterize or have a look at the state of future potential sites where we can work. And it gives us regulatory authorizations for this. We've also carried out BASI protocols, which is before after control impact protocols. And in our adaptive monitoring, we've worked with all pilot sites, experimenting different things, and we have carried out monitoring here over a 10-year period. And these are sites we're prioritizing for research, which are going to be monitored through agreements with Strasbourg University, l'INRAE, or perhaps LNHE. And this adapted monitoring is to help us understand whether the measures that we're implementing are effective, and also to understand the antagonistic effect of other anthropogenic pressures, for example, climate change, pollution, or invasive species like gobies. So the main results, I think I'm running out of time here, but the main outcomes is that it's very effective to restore this continuity. The studies have shown that we have beavers coming back to the Rhine. We have this passage between the two rivers with very effective systems. We've seen a biodiversity restored, particularly with what we've installed on the Thames Island and the forest, which have seen we've gained enormously in terms of biodiversity on this island. For all the different taxonomic groups, particularly aquatic biodiversity for the small Rhine. And what we've seen is that it's a very fragile environment still. And the problems with water quality, there's residual pollution in place from upstream, and there's issues related to climate change and global warming. And if we look at the alluvial dynamic restoration in terms of the minimum flow conditions, it's favorable for the temperature conditions, but in terms of vegetation, this is relevant, but not necessarily for the fish species. There's a high level of local erosion, which will stay in place as long as the groins are in place with the creation of this limits. We need to limit these exotic species, and this sedimentary replenishment will have little effect on the biology of the area, and rather it promotes these goby species, these exotic invasive species. And in the end, what we've seen over this period from 2010 to 2020, a functional shift the Rhine with ecological adjustments which haven't been stabilized yet. Particularly the impact of these invasive exotic species. And these non-native species have come to the Rhine, and they arrived when we were doing this restoration work. So as a conclusion, what we found to be very important is for rewilding projects to have an integrated, systematic vision and to work on the long term over 20 years. And that means securing budgets for this as well, so that we can adapt the measures that we're implementing. It's essential also to set up pilot sites and experimental sites so that we can check the efficiency of the work we're doing and also to learn from any relative failures. Adaptive monitoring is complex, but it's very useful to help move our knowledge forward and to adapt projects. It's important also to have regular discussions with stakeholders about all the different difficulties in the project developments. And what helped us with this project was to have integrated engineering for steering these scientific partnerships. And the main challenges here that we faced were not technical or scientific, but rather financial and societal. We were almost the only ones to fund this through the concession renewal, and it's a transnational river as well. So from the right bank and the left bank, we have cultures and visions which are different in terms of restoration. We have regulatory statuses which are specific to each country, and a coordination body, the CPR, which was very far removed from our issues. There were also issues in relation to invasive alien species, how to manage them. Should we be managing them on our own? And there were regulatory issues on the French side as well, as we're working on islands that have evolved a lot over the last century with their own diversity, which is not the same as the former Rhine biodiversity. There are quite a lot of protected species and regulatory issues which caused quite a lot of work for us. In terms of the environmental impact, we're very, very happy with what we managed to do despite some imperfections because we saw significant improvements in land biodiversity. In terms of aquatic biodiversity, the effect was less so. In terms of other anthropotic pressure, we had improvements in the landscape, and also we've been able to confirm the importance of refuge areas and biodiversity reserves. So for the follow-up now, we'll be continuing our work, of course, and we're going to adapt our action plan over the next 10 years. We'll be moving away from an experimental approach to move towards a regular routine approach. There are questions still to investigate that we're still raising about the resilience of biological communities, the effect of climate change, the place of invasive alien species, and societal issues as well, all around restoration projects. So I'd like to thank all our partners of this project. Some of them will be here for the panel discussion, the PCA Natural Reserve, the CNRS, and a certain number of design offices and stakeholders who have joined this project and helped us carry it out. So thank you very much to all of you.